Now that we know how to set up our trig ratios, it's time to learn how they're actually useful for solving problems. Since the trig ratios relate an angle and two sides, let's say you were missing one of the sides or even the angle, you would be able to use these relationships to find the missing side. So if I wanted to find this side x, figure out how long that side is. Now since this isn't a 30, 60, 90 or a 45, 45, 90, I don't have any sweet tricks for figuring out what to multiply or divide by. So I would be stuck using a sine, a cosine, or a tangent. Since I have this 35-degree angle, and I know the hypotenuse, and I wish I knew the adjacent side, can you tell me, am I going to use sine, cosine, or tangent? Well, probably we should write down our SOHCAHTOA again. And it looks like I have an H and an A, so cosine would be the one to go for. So I would write cosine of 35 degrees is equal to adjacent over hypotenuse, COH. So that would be x over 16. And there's an equation that has a variable in it, and you should be able to solve, right? If I wanted to get this x by itself, how would I get rid of a divided by 16? I would multiply both sides by 16. Another way to think of that is we can always put this over 1 and think about cross multiplying. I would take the cosine 35 degrees times the 16 and have that equal the x times 1. Either way, we're going to be taking that 16 times the cosine 35, and that would equal the x times the 1. And now we just have to type in 16 cosine 35. So we're back to our calculator. If you set it up last time to be in degree mode, it should still be in degree mode, but it's worth a check. Sometimes on your calculator you might even see a little D in a little box or something to show you that you're in degree mode. For mine, I have to push the mode button and make sure that degree is highlighted. What I want to type in is this 16 times cosine 35. And I get about 13.106. And that actually tells me the length of this side of the triangle. So cool. Here's an example if you knew what elevation you were at on your mountain and you knew how steep of a mountain it was. That would be enough to calculate how far we're actually skiing down that mountain. They use this term angle of depression is 21 degrees. That means like normally you look straight ahead, but if you're skiing down a mountain, you're naturally going to look downward. So they call that an angle of depression. And so the angle of depression is that 21-degree angle. I actually have two right triangles here, but I think I'm going to focus on this one since I have that 1200 labeled over there. And I'm really trying to figure out how far I'll be going down that mountain. So if my 21-degree angle is the one I'm using, I'm actually looking for the hypotenuse this time, right? And the 1200 represents the opposite side. So I'd be looking for a trig function that involves an opposite and a hypotenuse. And I think the winner there is SOH. So I will set up sine of 21 degrees is equal to opposite over hypotenuse. And the x is on the bottom here, which confuses some people. So we're just going to put that over 1 and we're going to cross multiply. So this time we'll be taking sine of 21 times x and putting it equal to 1200 times 1. That's what we get from our cross multiplying. Now you'll notice that the x still isn't by itself on this one, so I'll need to cancel out this times sine of 21. How do you cancel out a times sine of 21? You'll divide by sine 21. Whatever you do to one side, you'll have to do to both sides. And so then I would be left with just an x over here, and x will equal whatever 1200 divided by sine 21 degrees equals. And let's put a label on that. I think it makes sense because that's a very big number, and this is a hypotenuse I was finding, so I was looking for a big number. And since that elevation was in feet, my answer is also in feet. So the point of these trig ratios is really to find things, to calculate the measurements that you don't know. Here we've got a rope and it's attached to the ground 20 feet away from the base of the building, and it's forming an angle of 58 degrees. They call that the angle of elevation because going straight forward and upward is called an angle of elevation. And they're asking me to find the length of the rope, so I'll be looking for this side. I have the angle, I'm looking for the hypotenuse, and I'm also given the adjacent. So it's looking like cosine is the right one to use this time since I have an A and an H. Cosine of 58 degrees is equal to A over H 20 over X. And then we just have to solve. We'll take the cosine 58 times X, set that equal to the 20 times 1. This one, the X still isn't by itself, so we'll divide both sides by cosine 58. So the rope is 37.7 feet long. This one, it looks like we're gonna have to draw our own triangle. It says a surveyor, somebody who's surveying, is standing 118 feet away from the base of the Washington Monument. And the surveyor measures the angle between the ground and the top of the monument, this angle right here, to be 78 degrees. And we can use those two measurements, which we could totally do those measurements from the ground. We can use those to find the height of the Washington Monument. Since we're talking about this angle right here, it looks like we're trying to find this opposite side, and we know the adjacent side. The hypotenuse didn't really matter to us this time. Which one uses opposite and adjacent? That's TOA. So I'll be using tangent of 78 degrees is equal to that opposite over the adjacent. So I'll be taking the tangent 78 times the 118, setting that equal to the H times 1. This is one of those that's already set up just to type in. 555 feet. 555 feet. Love it. So our goal today was to see how those trig ratios can help us solve problems, how we can use them, and we are able to find those missing lengths of right triangles using our ratios.